we are about to get images of 3 Atlas that are the best resolution ever, simply because it comes so close to Mars.
There are secrets the world is not ready for. According to experts like Michio Kaku, we are living through the discovery of one right now. The object known as 3I Atlas is not what it seems, and after its Martian flyby, a wave of unprecedented silence washed over the globe's space agencies.
Well, these are really rare so far. It's only the third one ever. There's, 1.5 million known asteroids, and there's about 35,000 near-Earth objects.
But the thing nobody tells you is that China's silence is the key. They had the best view, the best technology on site. Their refusal to release a single pixel of data proves one terrifying thing. They saw something NASA can't handle, and they're all scrambling to figure out how to tell us. What the world's space agencies are hiding. Within mere days following 3I Atlas's close encounter with the Red Planet, the most powerful transmission emerging from our solar system wasn't a radio wave or a chemical signature. To put it mildly, it was the deafening sound of absolute silence. You see, this isn't the natural breathing space scientists typically take while instruments are recalibrated. No, what many people overlooked is that this appears to be a coordinated informational blackout, coming at the same time from every major space-exploring nation on Earth. NASA offered a seemingly reasonable explanation. A government funding freeze created bureaucratic paralysis, strangling public communication channels precisely as this historic moment unfolded. The European Space Agency maintained their observational data remains locked in processing pipelines. But here's the kicker. China, whose Tianwen-1 orbiter has generously shared more than 14,000 Martian photographs since 2021, offered absolutely nothing. No official statements, no preview thumbnails, not even a single placeholder sentence. In an era of instant high-resolution imagery, this information void has paradoxically become the most extraordinary data point of all. Under normal circumstances, this event would have triggered a planetary scientific celebration. Consider the lineup of assets positioned for observation. NASA's Mars Reconnaissance Orbiter carries the HiRISE imaging system, a piece of tech so sophisticated it could theoretically resolve details the size of a dinner plate on the Martian terrain from over 150 miles up. Europe contributed the Mars Express. The United Arab Emirates positioned their Hope probe, and China stationed Tianwen-1 in optimal viewing geometry. Every single platform stood ready, perfectly aligned to capture humanity's closest look ever at an interstellar traveler. This geometric configuration won't happen again for hundreds of years. Based on every historical precedent, we should be drowning in images and data. Instead, the information stream has become an unexplained vacuum, and like the mysterious void separating galaxies, this silence begs for careful interpretation. So, what's really going on? An American funding crisis can temporarily freeze public-facing websites, but it doesn't stop the science. Deep inside Mission Control, servers keep processing, and spacecraft keep sending data. What actually ceases during these shutdowns is the public theater of science. But this is precisely where international partners were expected to fill the gap. The European Space Agency operates independently of Washington's chaos, and China, whose space program expertly combines technical achievement with strategic communications, seldom misses a chance to shine when American capabilities falter. What many overlooked is that Tianwen-1 isn't just a scientific instrument. It's a geopolitical symbol, a technological ambassador projecting national prestige. So when a rival stumbles, Chinese space authorities typically accelerate their announcements. Yet, not this time. The silence is global. And for a theoretical physicist like Michio Kaku, this leads to a critical question. What hidden principle could possibly enforce such perfectly coordinated behavior across competing national interests? The truth is stranger than we can imagine, and it starts with the object itself. Y3I Atlas is no ordinary comet. Long before its Martian flyby, 3I Atlas had already compiled a remarkably strange dossier of unexplained characteristics. The thing nobody tells you is that this object breaks the rules of comets as we know them. For starters, its chemical ratio of carbon dioxide to water vapor is about 8:1. That's a molecular chemistry you'd expect to find in the frigid outer regions of a brand new solar system, not in typical comets from our own neighborhood. Then there's its spectroscopic fingerprint, which hints at nickel emissions appearing without their usual partner, iron. This creates a metallurgical imbalance that contradicts our standard models of how stars forge heavy elements. It's like finding a car made of engine parts, but no chassis. It just doesn't add up. What's more, despite having a luminous gas envelope around its nucleus, the object's trajectory refuses to show the characteristic wobble caused by outgassing. Every normal comet is like a leaky bottle of soda, with jets of gas pushing it slightly off course. 3I Atlas, however, follows gravity with almost mathematical perfection, as if the jets are perfectly balanced, or alternatively, its core mass dramatically exceeds all our brightness-based estimates. And if those mass measurements are accurate, placing it potentially several hundred times heavier than it looks, then 3I Atlas is in a completely unprecedented category. Consider its remarkable pathway, slicing through our solar system, and passing improbably close to Venus, then Mars, and eventually Jupiter. The statistical probability of such a grand tour has been calculated at less than 1% likelihood. It's like a tourist hitting all the major landmarks in a single perfect route by sheer chance. When you absorb all these factors, you begin to understand why top-tier researchers are increasingly using the word anomalous. Even its light-scattering behavior is unconventional, violating the optical rules that govern every comet we've ever studied. The playbook simply doesn't apply here. In response to these mounting mysteries, several research groups did what science demands. They ran the numbers. They performed rigorous statistical comparisons, evaluating natural versus artificial origin hypotheses, and returned with probability ratios that are, to put it mildly, jaw-dropping. Now, no researcher with a reputation to protect will casually claim they've found alien technology. Professional caution is the bedrock of credible science. Yet mathematics doesn't have a reputation to worry about. It just calculates probabilities based on evidence. When you multiply 7 statistically independent oddities together, the odds of this being just a weird but natural comet become vanishingly thin. This brings us right back to the deafening coordinated silence from the world's governments, managing a global alien revelation. This perplexing informational silence isn't necessarily a cover-up in the way most people think. You see, there are well-established institutional protocols governing exactly this type of extraordinary situation. These aren't the dramatized Hollywood scenarios we've been conditioned to imagine, but carefully constructed frameworks drafted by sober-minded scientists and policy experts for decades. Many people are crazy about the idea of a shadowy conspiracy, but the reality is more about prudent institutional risk management. The fundamental principles are simple. Verify observations independently, replicate findings across multiple platforms, and coordinate any announcements internationally. No single nation is supposed to make a unilateral public declaration before getting independent verification from multiple sources. This is the core of the post-detection policy. Stakeholders convene discreetly behind closed doors. They negotiate precise terminology and framing. Information gets released simultaneously across all parties, or it doesn't get released at all. This approach is designed to prevent a single nation from causing global panic or gaining an undue advantage from a discovery that belongs to all of humanity. Think about it. If Tianwen-1 had captured images of just an unremarkable dusty fragment tumbling past Mars, releasing that imagery would have been a communications masterstroke for China. It would have been a simultaneous display of scientific knowledge, technological prestige, and a subtle diplomatic jab at an American space agency paralyzed by domestic politics. The fact that no such release occurred suggests not a missed opportunity, but a deliberate, calculated decision to adhere to this global protocol. A decision that implies the observation was anything but unremarkable. This is the kind of situation that escalates beyond the astronomer's research office and directly into diplomatic conference rooms. Not because the instruments are panicking, but because human decision-makers certainly are. They have only one chance to carefully orchestrate humanity's potential first encounter with something that might prove to be far from mundane. So, what type of observation would justify this unprecedented pause? A blurry, indistinct dot wouldn't do it. But what many overlooked is that some things would. A sharp, geometrically precise structure displaying perpendicular right angles absolutely would. A rotational pattern that violates basic physics would. And evidence of a deliberately controlled trajectory adjustment would most certainly trigger this level of caution. The fear doesn't center on the object itself. The terror focuses on the catastrophic consequences of publicly mislabeling what it represents. Claims that could change our entire civilization demand proportional caution. The silence is a shield. But what exactly are they shielding us from seeing? A picture, worth 1,000 secrets. While we must maintain intellectual discipline, resisting the pull of sensationalism, it becomes an almost impossible exercise not to wonder what kind of image or data would trigger such a profound, planet-wide silence. This isn't a response to ambiguity. A poorly exposed, ambiguous streak on a sensor, or a blurry collection of pixels, would not trigger this response. That kind of anomaly would generate quiet academic debate, perhaps a niche paper on sensor artifacts, but it would not halt the global information pipeline. No, this kind of coordinated stillness is reserved for the unambiguous. We are talking about data that defies any and all natural explanations. Imagine a picture showing a surface texture with mathematical periodicity, a repeating geometric pattern, perhaps a series of unmistakable right angles, or faceted structures that catch the Martian sunlight in a way no random geology ever could. Or thermal imaging that reveals a localized, inexplicable energy source. This is the kind of data that would immediately trigger thousands of confidential emails stamped with "draft only" and "do not forward." This is the kind of data that would have laboratory directors frantically telephoning their international counterparts at midnight, not just to make sense of the unthinkable, but to first verify that their own instruments, their own teams, and indeed their own sanity were not failing them. The thing nobody tells you, the part that is often mistaken for a cover-up, is that this isn't about hiding aliens. It's about managing the revelation. It is the sudden, cold realization that the fundamental context of human existence has changed, and that the agency in charge of the announcement will be responsible for the day after. Could there be a simpler explanation? Of course, skepticism is our primary tool. Perhaps the high-tech cameras, optimized for the slow-moving, stationary Martian terrain, simply couldn't handle the parallax and angular velocity of a dim, rapidly moving object against the blackness of space. Maybe the science teams are still painstakingly distinguishing genuine image streaks from the constant rain of cosmic ray strikes that pepper every deep space image. But these explanations begin to wear thin when subjected to scrutiny. 5 completely independent competing engineering teams, from NASA, the ESA, Roscosmos, and the CNSA, don't all stumble over the same baffling technical problem during the same narrow window of observation. These are billion-dollar flagship missions, redundant and robust, explicitly designed to capture the unexpected. And even if they did all fail, professional embarrassment or technical confusion usually leads to carefully worded blog posts, damage control, and promises of future software patches. It does not lead to a complete, unified information blackout. This deliberate stillness, extending from Washington through Paris, Moscow, and Beijing, feels different. It feels measured. It feels like the precursor to a statement, not an admission of failure. This silence cannot erase the extensive ground-based record that already exists. The anomaly was tracked long before it reached Mars. The strange chemical signatures, the spectroscopy that defied classification, and the improbable trajectory that brought it so close to the red planet, all of that is already documented in astronomical databases. The ground-based data was the smoke. The Mars flyby was the chance to see the fire. What the silence can do is buy precious time. It allows for rigorous cross-verification, ensuring that what one agency saw is exactly what the other saw. It buys time for the careful, agonizing crafting of one unified, coherent narrative instead of 5 contradictory, panic-inducing ones. That approach doesn't necessarily make the narrative true in its entirety, but it makes the revelation potentially survivable for our institutions and our collective public psychology. The goal is not to deceive, but to inoculate against a shock that could shatter economies and faiths. Meanwhile, the object itself continues its journey in what can only be described as regal indifference to our human anxieties. It is an actor entirely outside our sphere of influence, a fact that is perhaps the most unsettling part of all. It's now receding from Mars, a fading point of light heading steadily toward the Sun. Come December, it will pass Earth's orbital neighborhood. It will pose no threat, maintaining a reassuringly safe distance of millions of miles. Yet, it will be close enough for our most powerful terrestrial and orbital telescopes, from Hubble and Webb to the ground-based giants in Chile and Hawaii, to absorb whatever revelations it chooses to unveil. People frequently ask thinkers like Michio Kaku if this is the transformative moment we've imagined for over a century. Is this that instant when the night sky transitions from a beautiful, passive backdrop into a mirror reflecting organized intelligence back at us? His response is always that of a seasoned, disciplined physicist. We will get knowledge only as fast as rigorous, peer-reviewed data analysis permits. And the universe, as always, stubbornly refuses to accommodate our impatient human schedules. If the combined spacecraft data proves ordinary, a bizarrely shaped rock, a unique cometary outgassing, or a complex instrumentation error, this global silence will be forgotten, dismissed as an embarrassing overreaction. 3i Atlas forced the world's rivals to act as one. Was this a test? And if so, did we pass? Like and subscribe for more answers to the universe's greatest questions.